Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 6 of a unit electrostatic potential and capacitance. In today's class we are going to discuss about the electrostatic potential energy and how we can define an electrostatic potential energy for a system of a charge. So before we go for the system of the charge, let's begin what electric potential energy is all about. How can we define it? Yes, so if I want to define it, then I can say that it is the work done on a point charge in bringing it from infinity, remember this word, from infinity to a point in electric field against the field is called electric potential energy at that point. It is the work done required to be done on point charge in bringing the unit test charge from infinity to that particular point against the electric field, and that energy, the energy stored in a body or energy of that system, is known as the electric potential energy. I hope those things are clear to you. Yes, so let's begin that how electrostatic potential energy for two charges of a system in an external field can be defined and can be derived. I know that you already derived it in your school classes. Yes, so this is just the revision point of view. We are going to cover this quickly and we'll move to the numericals. So let's move it. Yes, this is the Cartesian system having an x, y and z axis. This point as an O, it's considered as an origin, and we have two charges, as you can see, it's in q1 and q2. That let 2 point charges q1 and q2 are there, and at points A and B and their position vector. You always know that when we want to consider the position vector, we always choose an origin, and distance from the origin to that particular position can be represented with the help of position vector. So these are the r1 and r2 are the position vectors for the charge q1 and q2. Let's assume that v1 is the potential at location B due to q1, and v2 is the potential at A due to q2. Now if we know that what is the potential for a point charge, we know it is a k into q by r. So we know that v1 can be written as a k, it's in 1 upon 4 pi epsilon naught multiplied by q1 by r1, and v2 can be considered as in 1 upon 4 pi epsilon naught into q2 into r2. Yes, I always know that v is equals to work done by charge. Yes, voltage is work done divided by charge. So work done is always voltage multiplied by charge. So I can write like this, it's a v1 into q2, or it could be written as an v2 into q1. So if I simplify this, if I replace a value of any of this, then I can have its work done is equals to, or the potential energy stored is equals to k multiplied by first charge multiplied by second charge divided by separation between these two charges. This work done is stored in the form of a potential energy, and that potential energy can be considered as in k multiplied by first charge multiplied by second charge divided by separation between these two charges. This is the electrostatic potential energy for two charges when they have been placed in an external field. Yes, did you understand this? Are you sure? Okay, suppose there are three charges. Let's say the system would be something like this. This is x, this is y, and there could be a three charges. It's a q1, it's a q2, and it's a q3. Their position vectors can be redrawn as an r1, this position vector is r2, and their position vector this could be r3. And I want the potential energy to be find it out. I want that potential energy of this three system of charges. How could I do this? One of the simplest method is, you know that u is equals to k multiplied by q1 multiplied by q2 divided by separation between these two charges. So what you can do is, you need to just make a pairing having each pair must be having a two charges. So I am having three bodies, q1, q2 and q3. So let's make a pair of this. This is first body, this would be the second, and this would be the third. If the things are look like this, what I can have is, I can have a pair. First it's a 1 comma 2, another pair would be a 1 comma 3, and another pair could be of 2 comma 3. Yes, if you think that sir 1 comma 1 could be there, and 2 comma 2 could be there, 3 comma 3 could be there, no, this cannot be there, because potential energy has been defined between two different charges. 1 comma 1 represents the charge 1 only. Yes, one more question could be there, that sir if 1 comma 3 is there, there could be a 3 comma 1, yes or no? No, it is just the duplication process, because 1 comma 3, what you will write, it's a k multiplied by q1 multiplied by q3 divided by distance between 1 and 3. What you will write in 3 comma 1, yes, it is just simply the same na, that if you multiply 4 into 5 or if you multiply 5 into 4, this both are the same thing. So 3 comma 1 could not be there, because you have mentioned 1 comma 3. Same way you cannot assume 3 comma 2, because 2 comma 3 has been already considered. So I have done the same thing. I have make a first pair, it's a 1 and 2, second pair as a 2 and 3, and as a third pair it's a 3 and 1. So I simply write this, it's a k q1 into q2 divided by distance between this two, plus k into q2 into q3 divided by distance between this two, q2 and q3, and k multiplied by q3 multiplied by q1 divided by distance between this two. This represents the potential energy of the system. I can even like this. Yes, this is just the simplest form, or this is what we can say is a generalized term for potential energy, or rather I should say as an electrostatic potential energy for more than two charges. Yes, so let's begin. Let's done then. Suppose you have been given like this. This is q1, this is q2, this is q3, this is q4, this is simply a. As it is a square, there must be a same dimensions of each side, so this all are a. What they ask is that find out electrostatic potential energy, EPE. It's an electrostatic potential energy of the system. You need to do this. So how can you do this? First you need to give a number to each and every charge. It's a first, it's a second, this is third, and this is fourth. This is my first requirement. Now what can you do? You can make a pairs. Now the pairs should be start from 1. It's a 1 comma 2, yes, it's a 1 comma 3, yes, it's a 1 comma 4. Is there anyone which is left while starting with 1? No, it is not. 1 comma 2, 1 comma 3, 1 comma 4 is there. Now make a pair starting from 2. It's a 2 comma 3. 2 comma 1 could be there, but it is a 1 comma 2, which is a duplication, so I could not write 2 comma 1. It's a 2 comma 3 and 2 comma 4. Yes, and next let's make a pair from 3. It's a 3 comma 4, because other pairs have been already included. And you if you think to start from the fourth, it's a 4 comma 1 already there, it's a 1 comma 4, 4 comma 2 already there, 4 comma 3 it is always there, and 4 comma 4 does not exist. Yes, I hope those things are clear. Always remember, whatever the number of charges could be, there would be always n into n minus 1 by 2 number of pairs could be there. Always, this is the case of always. So this will help you, that if suppose by chance you have forgotten to write any one of the pair, then you can directly have a clue that these are the 4 charges. So this is 4 multiplied by 4 minus 1, it's a 3, 4 3s are 12, 12 divided by 2. So there are 6 number of pairs could be there. If it is there, you may have written it correctly. If it is not, If it is not, you need to again go through this and again need to make a pair and do this task again and again until you are getting n into n minus 1 by 2 number of pairs. I hope these things are clear. So this, up till now we have just formed the pairs of the charges, that 1 comma 2 is there, 1 3 is there, 1 4, 2 3, 2 4 and 3 4. Now you need to focus on the pairs and write down the potential energy. So that potential energy you can be, it's a 1 comma 2, so k multiplied by first charge, it is q1, multiplied by second charge, it is q2, divide by separation between these two, it's an a, plus now it's a 1 comma 3. Look at here, this is first, this is third, so their separation is, this is a, this is a, this is hyper, this is 90 degree, and if it is 90 degree according to this, according to the Pythagoras, it would be a root 2a, that you know, it's a k q1 q3 divide by root of 2a. Now turn for 1 comma 4, this is 1, this is 4th, so what you will write, you are going to write it as k multiplied by q1 multiplied by q4 divide by a, plus 2 comma 3, it's a 2 comma 3, it's a k q2 q3 divide by a, this has been done. 2 comma 4 plus k q2 q4 divide by root of 2a, plus 3 comma 4 last pair, it's a k q4 q3 divide by a. This is the total potential energy of this system. I hope these things are clear to you. Yes, is it clear? Yes, yes, when we are writing that potential energy is k q1 q2 divide by r, we mean that we have considered that potential energy at infinite is assumed to be 0. When we write this, u is equals to, or potential energy is equals to k q1 q2 by r, we are writing this when we assume and when we consider that my potential energy at infinite is 0, then and then we are capable enough to write this. I hope these things are clear to you. Is it? Yes? So ready for the next question? Any doubts? No? Let's move on. The next question is, let's say this is a triangle, it's a writing equilateral triangle, sorry. This charge is plus q, this charge is minus q, this charge is again plus q, their separations is a, the separation is a, and its a separation is a, and you have been asked that find out electrostatic potential energy of the system. You have been asked this, that find out electrostatic potential energy of the system. How can you do this? Yes, what was our first step? Yes, give them a number, it's a first, let's say, let's suppose this is second, and let's suppose this is third. Now three charges are there, let's make their pairs. So when I make a pair, it's a 1 comma 2, next it's a 1 comma 3. Yes, next let's begin with 2 comma 1, it is already there, and 2 comma 3. Okay, so 3, it's a 3 comma 1 available here, 3 comma 2 is available here, so no need to write a pairs from 3 comma someone else, because it is already there. Yes, so up till now, is it clear? Is it? Can you do this? Are you sure? Now you need to write a potential energy, but before you write a potential energy, always consider a charge with its sign. I repeat, you need to always consider the charge with their sign. Please remember this. Yes, so let's begin. It's a 1 comma 2, that means k multiplied by q multiplied by minus of q divide by their separation, it's an a. Next, it is the 1 comma 3. It's a k multiplied by q divided by separation between them. It's an a. 2 comma 3. It's an, this is plus k into q into, this is minus, so minus of q multi divide by a. So if I write this, it's an k minus of kq square by a plus kq square by a. This is minus of kq square by a. This plus kq square by a and minus kq square by a would be a cancelled, and the minus of kq square by a, it is the answer. I hope those things are clear to you. Is it? Is it? Any doubts? Any difficulties? No? So can you do this with me? Are you sure? Yes. Let's have your pen and paper, and from next questions and onwards you are going to calculate this. You are going to calculate this with me, and at the end of the slide we are going to matching the answer. Let's have it. You are going to do in your book. Yes. Let's suppose the charges are given as, that this is q, this is plus 2q, this is minus of 4q. The separation between q and 2q is 2. It's a, let's say 2 meter, and this is again a 2 meter. They said that find out electrostatic potential energy of the system. This is their requirement, that find out the EP of the system. How can you do this? Yes, how can you do this? Let's say this is first, this is second, this is second, this is third. Yes, 3 charges are there. It's a first, second and third. Next, you need to make a pair. So it's a 1 comma 2 first, 1 comma 3 second, and 2 comma 3. Yes, 3 charges are there. It's an n minus 1 by 2. So 3 into 2 divided by 2, it's a 3. Yes, so we did correct up till now. Up till now we are on the track. Now we need to find two potential energy of the system. How can I do this? How can I do this? So what I can have is, that is the u is equals to, let's say k multiplied by first charge, it is q, multiplied by second charge, it's a 2q, divide by separation, it's a 2. 1 comma 3 now, plus k multiplied by q multiplied by minus of 4q, divide by their separation, it's a 4 meter, plus it's a 2 comma 3, then it's a k multiplied by 2q multiplied by minus of 4q divide by 2. Yes, so this 2 would be a gap, this 2 would be a gone, and this 2 would be a gone. So what the things remain, it's kq into q, it's a kq square, this is minus of k into q square, and this is plus q into minus of 4q, so this is k into minus of 4q square. I hope these things are clear. So this is plus kq square, this is minus kq square, so this should be is equals to minus of 4 into k into q square in terms of the joule. Yes, because this is the potential energy. Yes, potential energy can be a negative. I hope you know this, and this is the proof of the same. Potential energy can be a negative, and this is the proof of it. Is it clear? Yes. So will you be able to do this kind of terms? Will you? Are you sure? Can you handle this kind of questions? Will you be able to do this? Okay, let's have one more question on same pattern. It is q minus of q minus of q plus q. This is a, even this is a, as it is a square, so the rest of the sides are always having a dimensions of a, that we know. Yes, they have asked that. Find out of the system, find out EPE of the system. You know what EPE means. Yes, so this is find out the electrostatic potential energy of the system. How shall we do? What is my first task? Yes, my first task should be to provide them with numbers. It's a first, this is second, this should be third, and let's say this is fourth. Yes, so this is first, second, third, and fourth. Now now let's have a pairs of there. It's a 1 comma 2, 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 4, and 3 comma 4. I hope these things are clear to you. Yes, now what next? What next? Yes, just rewrite according to the pairs. It's a u should be is equals to 1 comma 2. This is first, this is second, so this is k into q into minus of q divided by their separation. It's a. Now it's a 1 comma 3. This is first and this is third, so this is equals to plus k q square divided by their separation. This is a, even this is a, so their separation is root 2a according to the Pythagoras. Yes, next it's a 1 comma 4, so this is plus k into q into minus of q divided by their separation. It's an a. Next is the turn for the 2 comma 3. Next is the turn for 2 comma 3. This is 2, this is 3, so this is plus k q minus of q divided by a. Next it is the 2 comma 4, so this is minus of k q square. 2 comma 4, it's a minus minus plus k q square by root 2a. And last it's a 3 comma 4, it's a minus of, it's a minus of k q square divided by a. So look at this, if I solve this, it's a minus of kq square by a, even this is minus of kq square by a, even this is minus of kq square by a, even this is minus of kq square by a. So the term will remain is minus of 4 kq square divided by a plus this is kq square by root 2a plus kq square by root 2a. So this is 2kq square divided by root of 2a. So the number that remains is, it's a minus of 4kq square by a plus this is 2kq square by root 2a, so this is root 2 k q square divided by a. This is the term that should remain. Yes, I hope these things are clear. Get this? What is your answer? Is it same? Are you sure? Great work. So let's move to the next question. Suppose a triangle is there. It's an equilateral triangle having sides a. Yes, and they are having a charges as plus q, plus q, plus q. Now listen the question very carefully. They will ask that find out work done require to separate the charges by distance of 2a. Yes, what they ask? They ask that find out the work done required, find out the work done required to separate the charges by a distance of 2a. This is what the requirement is. So how can I do this? How can I do this? What could be the process, and before the process, how could I arrange them, or what should I do so that I can get the work done for this? Do you have any idea? Do you think for a while? Yes. Anything in your mind? No? Okay. Let me give you the hint. Do you know that in unit number 5, class 11, work power energy, you may derive the formula that is work done is equals to, basically it's a minus of change in potential energy. But at this point of time, if we are interested in only a magnitude, let's say if at this point of time we are interested in only a magnitude, then it could be a work done is equals to mode of delta u. Actually it is minus of delta u, but let's say at this point of time it is work done is equals to delta u, or it's a change in potential energy. Yes. So if it is there, what I can have is, currently I'm interested in magnitude only, then I will decide that whether it would be a positive or negative and something like this, but currently working with the positive only. So let's say that work done is equals to u final, it's a final potential energy minus of initial potential energy. But what is final potential energy and what is initial potential energy? How could I have an idea? What could I do? So these are the questions, which are the question basically of reconfiguration of your structure. This is the question where you will reconfigure your structure. That means your structure would be having certain separations, or your structure may have a certain sort of charges, and you are going to segregate them by, you are going to change their separation air, or probably you are going to remove one of the charges, and this all kind of stuff are known as the reconfiguration of the setup. And when you require to reconfigure your setup, you always need to do this, that write down the initial potential energy, write down the final potential energy, and then just subtract it. That's it. So let's begin first. This was the initial system. Their separation were a, this is a, and their charges are plus q, plus q, plus q. This is the initial. Now final, this is 2a, this is 2a, this is 2a. This is the final system. So my final system should look like this. Now what should I do? Yes, I need to perform the same task. What? That prepare a pairs. It's a first, it's a second, it's a third. Always name the charges intelligently, because if you have given name 1 here, always give a 1 here, 2 here, that means 2 here, 3 here, that means 3 here. This will save my time. How? Because I don't need to write the pairs for twice. I can just make it once and things will be done for both of the systems. So if I make a pair, it's a 1 comma 2, it's a 1 comma 3, and it's a 2 comma 3. I hope these things are clear. It's a 1 comma 2, 1 comma 3, and 2 comma 3. So if I write the initial potential energy, it's a 1 comma 2, this is k q square divided by a, plus 1 comma 3, it's a k q square divided by a, 2 comma 3, it's a plus k q square divided by a. So this would be 1 2 3, it's a 3 k q square divided by a. Yes, you can use the same pairs for final as well. So you have, it's a k q square by 2a plus k q square by 2a plus k q square by 2a. So this will be 3 k q square by 2a. Yes, I hope these things are clear to you. Is it? Is it clear to you? Now, we are going to do UF minus of UI. We are going to perform this. It's a UF minus of UI. So, this is final. It's a 3kq square by 2a minus of 3kq square by a. So, the remaining term would be minus of 3kq square by 2a. This is the work done required, Joule. This is the work done required. I hope these things are clear to you. Is it? Is it? Yes. Are you clear with this? And until this, are you sure? Yes. Then shall I add something? Then I shall add something. That if I add that, here only ask that find out the work done required. If now suppose they ask that find out work done require by external and internal force. Yes, this is what they require. They require that you find out the work done by an external and internal force. Now, how can I do this? Yes. Did you perform same kind of questions in gravitation as well? Did you? Have you gone through this? Same kind of questions that here the charges are there and at those places masses would be there, such as here it is a k q1 q2 by r. In the gravitation it would be a minus of g m1 m2 by r. Have you gone through this? Yes? Great. If not, don't worry. I am here to guide you. Yes. So this is initial potential energy. This is final potential energy. We have already find it out the work done. Now they ask that tell me the work done by internal force and tell me the work done by external force. So for that, to answer this kind of question, let's go through certain conceptual objects. That let's suppose that we know that which is the internal force and which is the external force. We always says that internal force is a one which acts between charges from their internal property. Now again one question arises, what is the internal property I am talking about? That if one of the charges q, another charge is the q, then there is a force of repulsion. Why this happens? Because of their internal property. If it's a q and it's a minus of q, then they will attract. You does not need to perform anything to make them attract, or you do not need to perform anything to make them repel each other. They are going to attract or repel by themselves only. So whatever the forces that acts by their internal property, those forces or that kind of forces is considered as an internal forces. And we can say that whatever the forces that acts in opposite to the internal forces, opposite to the internal forces, that are known as the external forces. I hope these things are clear. If internal force says that we will repel each other, then external force must say that No, you need to attract each other. If internal force says we are going to attract each other, then external force must say that nay, you need to repel each other. So this is the some kind of internal forces and external forces could be there. Yes. So now let's come back to our case, that initially the separation was A. Now the separation is 2A. This are the initial, this is the final situation. This was the initial, this is the final. Yes, this is Q, this is Q, and this is Q. This is 2Q, sorry, this is Q, this is Q, and this is Q. I hope you remember this. Yes. Yes. So what was the situation? The situation was that initially their separation were A, and now their separation is 2A. So they have repelled each other. First thing, they have repelled each other, then and then they have separated from A to 2A. I hope these things are clear. Yes. Second thing, this is plus Q, this is plus Q, so they must repel each other. Yes, they are having force of repulsion. They are having force of repulsion within themselves. Yes. So what I can write is now let's look at this very carefully, that their force wants to repel each other, and that even they are going to displacing in this direction. So this is the internal force. Now the angle between, go through the work power energy class 11 unit number 5, the direction between internal force and displacement, it is the same. So what I can have is work done due to internal force should be positive in this case. Work done due to internal force should be positive in this case. Now what about the external force? Force always expects that if internal force say we are going to repel, then external force says you need to attract. That means external force should be acting on this direction, and these people are displacing in this direction. So here the angle between force and displacement is 180 degree. Here the angle between force and displacement is 0 degree. Yes. So work done due to external force should be a negative. Work done due to external force should be a negative. So now what I need to do is that simply do this, that this is your initial system, this is your final system. Just write down that what is the initial potential energy of the system. When I say initial, I mean whatever the before any modification, what was the potential energy of the system. That potential energy of the system will be known as the initial potential energy. After modification, it should be written as an UF, it's a final potential energy of the system. Then write or calculate W is equals to UF minus UI. Even you can do UI minus UF, that doesn't make any difference, because we are going to now decide that whether this answer should be a positive or negative. So when I perform, in our case work done is equals to UF minus UI, my answer was minus of 3 by 2 K Q square by A. Yes. Now what I assume is that my work done due to internal forces should be in positive. So if I considered work done due to internal forces should be a positive, so I just make this answer as a positive and write it as it is. It's a 3 by 2 kq square by A. Yes, I hope this seems clear to you. Okay, my Work done due to, let's say, external has been asked, work done due to external force has been asked, and that force should have a negative answer. It is already negative, so you do not need to do anything, and this is just your answer. This is minus of 3 by 2 into kq square by a. Yes, yes, is it clear? Is it clear? Now look, there are certain reference books, or there are certain other contents that always ask us that when and when you need to perform work done due to internal forces, then you need to do ui minus uf, and when work done due to external is asked, you need to perform final minus initial. But what I assume is that that cannot work every time, but this kind of sense and this kind of assumption and this kind of logical behavior will work for you people always and 100%. So what you need to do is you need to just identify that what my internal forces says. If whatever they are saying and your particle is displacing in the same direction, then work done due to internal forces would be a positive. If particle are moving in opposite direction, if particle are moving in opposite direction, then what internal forces are saying, then it would be a negative. And if internal work done is negative, then external work done must be a positive, because whatever the internal forces are mean to, external forces are behaving exactly in the opposite sense than the internal forces. I hope these things are clear. These are very, very logical points. Please do remember. Please do remember. Yes? Okay. So, shall I add one question to this? Shall I? Yes. Let's that in the previous question. Find out work done require to separate charges by a distance of a by 2. Yes. So my initial system should look like something like this: plus q plus q plus q. Their separations were a, and now my final system should be q q q. This is a by 2, this is a by 2, and this is a by 2. Yes, you also need to find out that work done due to external force and work done due to internal force. I hope you can do this. Yes, can it be done? Can it be done? Are you sure? What you are going to do? Yes, first write down the ui, then write down the uf, then perform that ui minus uf, or you can perform uf minus ui, because after the answer is arriving, you are going to decide that whether it is positive or negative based on the behavior of internal forces and external forces. I hope those things are clear to you. Is it? So can you do this? Can you do this? Are you sure with this? Yes. Yes, so let's sign it out for this class, and when we are going to meet in the next class, we are going to see some more applications, some more questions of the electrostatic potential energy. Till then, bye bye, have a good day, take care.